Okay, let's talk data structures. For doing analyses in Python and R, you're going to have to think a little bit differently for how you organize your data set than you did for SPSS. So I'm going to give you an example, walk you through this example in both Python and in R, and I'll share this data with you via Google Drive so you can work with the same data set that I'm working with. But let me explain the study that we did. So this is a recent study that we did. So we had a basic recognition memory experiment. So people saw some words and then later they were asked to identify which words were old and new. So as it turns out, you have a variable, we're going to call it item, and you have old words that are called old. That's a correct judgment. Those are called hits. We have old words that are called new. That's a mistake, and so we call those misses. We had new words called new. They're called correct rejections. And then we have new words that are called older. That's false alarms. So we have four kinds of essentially responses that that can be made in the combination of the item type and the response type. So that's one variable that we have. And by the way, this is all within subjects, all repeated measures. Then we had two tests that people did. We had one where they were asked if the item was old, and they're making yes, no judgments. And then what we did is we varied the question. And so in another test, they were asked, is the item new? And they were making yes, no judgments. And what we wanted to do, the larger picture here is what we were doing is recording ERPs while they were doing these two different tests. So it's all repeated measures. Those are the two variables that we'll be working with. The other thing you'll see in the data file is that we can form proportions for the items, but we could also measure response times for each one of these. I'm not going to mess so much with that, but that's in the data file. So when you sort of see that, largely ignore that, but we could do the same analysis for either proportions or false alarms, whatever we wanted to do, whatever the case might be. If it's entirely repeated measures design, our data file would have a certain structure in SPSS. So let me sort of illustrate what you would be used to seeing in SPSS. So we would have a subject number, we'd have a variable for subject number, so subject 103, for example. Actually, let me go ahead and we'll just put subject identification number, and then we're going to have variables for each one of these, or names for each one of these variables. So usually I would do something like you would have OT for old test, and then you would have the item type. So we would have hit, and then you'd have old test miss, old test correct rejection, old test false alarm, and then we would have the same thing for the new test and variables over here. I'm just going to change the variable names so that we have a unique variable name for each case here, and each subject would have one row of data. So we'd have like subject 103, and I'm copying some data. Copying some data here from another file. So just bear with me as I sort of look and type at the same time. And I'll just give you this will just give you an idea of the structure here. Okay, and then subject 104, next subject would appear on the next line. In your case, if you're wondering what happened to subject 101 and 102, well, subject 101, we had a program error. Subject 102 didn't understand the instructions, so that's why it starts with 103. Often happens when you're first collecting data. Anyway, subject 104's data would appear on these lines and so on, and you would do your analysis in SPSS like that. Now, if we had a repeated measures, if we had a mixed design and we had another variable which was between subjects, you're used to doing this, where you would insert and you would have a column, and you'd have some sort of grouping variable, and you would have a dummy variable where the coding is 1 for everybody in the first group, 2 in the second group, and so on, right? So that's, you're used to that, and then you integrate those into your commands. Well, as it turns out, that data structure you're going to have to sort of reject and use a different data structure. So this is what's called wide format, and instead of wide format, Python, Pandas, and R likes and uses long format, which is actually a lot easier once you get used to it, but I need to sort of introduce you to this idea. At first, I was like uncomfortable with rejecting this way of thinking because I'd used it for so long, but now I've grown to love the other way. So let me show you. Yeah, I'm not gonna say this, don't care about that. So here's what the data file really looks like. Same data, but it really looks a little bit different. So now each subject has several lines of data going all the way down. So this is our entire data set. So several lines of data. Then we have a variable for test, and we have our code. It can be a string, so like it doesn't have to be a number. So it could be OT for old test, NT for new test. We could put whatever we want to in here. We could use codes, but codes are easy to forget which group is which. So this is much better because you don't have to forget which is which. So here's our items: hit, misses, correct, rejections, false alarms. And then here's our dependent variable. So prop just is proportion. So this is the proportion of hits, misses, correct rejections, and false alarms. And then RT, of course, is response time to make those individual judgments, right? So that's our data structure. This is what's called long format. And you want your data in this format. Now, I'm going to do a different video that will show you how to write code for Python to convert wide into long format. You can also do some stuff if you do some videos. You can do this in Excel. Here we're using Excel, and by the way, our data files are comma delimited data. So they're read in Excel, but they're comma delimited format. So that means that when you sort of open this up, it just has 103 comma and so on. But you could do this in Excel and save it as long as you save it as a CSV file, you're good, and you could read it in. So you could morph your data in Excel if you want to. I would write code. I do write code to modify the data files. I use a different programming environment right now, converting over to using Python. So I'm going to do a video a little bit later that'll show you how to do some conversions in Python to morph your data files into this manner if you have that issue, depending on what package you're using to actually collect your data. But this is the data file that you want to have in long format. By the way, if you're using, so for my students who will use MATLAB and EEG Lab, you can output the EEG data into wide or long format, so you have that option, and I'll show you here in just a second. Okay, so if you're using ERP Lab to dump out ERP data, so you would click ERP Lab, you're going to click the ERP measurement tool. You'll get a different window. The ERP measurement tool window looks like this, of course, and you're going to load up your data set. You're going to select whatever your measurements are. The key here for the data format is, if you notice right down here, you see where you have the option of one ERP set per line. That would be the wide format. We don't want that. You would want to select one measurement per line, the long format. So you just select that output, and then you would click run. It dumps and creates your data file. Now, I have found that you have to clean up that data file a little bit. I can explain that in more detail, but I write programs locally to take care of that, to clean it up, to create a CSV file, in effect, that can be easily read by Python or R. So there is one more intermediate step that you would have to do. It's not quite compatible yet. We need to work on Steve Luck and the crew to get that fixed. But that's essentially the data structures that you need for doing analysis in Python and R.